This video is a short presentation about levels of measurement and analysis. For those of you viewing this video for one of my statistics classes, this video contains concepts with which you must be familiar throughout my courses. The term levels of measurement refers to the existence of different types of data. Specific variables in a data set fall into one of two categories, categorical or numeric. This split is also referred to as qualitative versus quantitative. These two categories can be divided further. Nominal and ordinal variables are types of categorical data. Interval and ratio variables are types of numeric data. Knowing the level of measurement that you have is important for two reasons. First, the type of data you have determines which statistical procedures are appropriate. Certain procedures are used with qualitative data, other procedures are used with quantitative data. There are also guidelines about what to do when applying multivariate statistics to a mixed group of variables. I often say statistics is about judgment. What I mean is that you have to think about the types of data that you have and then apply the appropriate statistics. Often I give classes a chart like the one shown here to guide the choice. In addition, in my final statistics projects, depending on the class, 20 to 25% of the grade is tied to making these judgments correctly. The second reason for knowing the level of measurement is tied to how computers store data. Categorical data is often stored in a numeric format. Here we have the county-level crime rate data that I use as an example in several of my videos. This screenshot here is of the variable view in PSPP, and I have highlighted the variable region, which refers to the region of the country in which a county is located. Note that this variable is labeled as numeric. If I run descriptive statistics on the variable region, the output here is a possible result. In the top box, we see a frequency distribution for the four categories of region: Northeast, Midwest, South, and West. Because region is stored as numeric, we can also describe region in terms of numbers, 1 standing for Northeast, 2 for Midwest, 3 for South, and 4 for West. The bottom box contains statistics appropriate for a numeric variable. The mean is a statistic appropriate for a numeric variable, and the output here shows us that the mean of region is 2.73. What does this value represent? The answer, nothing. It is ludicrous to say that region has a value of 2.73. Region is in fact a categorical variable, and the frequency table at the top of the output is the correct way to describe the data. The box with descriptive statistics on the bottom of the output is incorrect. Students in my classes frequently get region wrong because they don't think about the types of data. They give me the bottom box as an answer to questions about the descriptive statistics. If this is the case, you may be wondering right now why region is a numeric variable in the file at all. The answer is simple. Numeric variables take up less storage space on a computer than categorical ones, so it is a common practice to store categorical data in a numeric format whenever feasible. The region names that you see in the top box are labels that I added later, but they do not reflect how the data is stored on the data file. If you are paying attention to the levels of measurement, this quirk should not be a problem for you. Let's look at the 4 different levels of measurement. The term nominal refers to data in which the categories have no intrinsic order. Nominal is tied to the Latin root for the word name. Nominal data means simply that data represents the names of categories. All 4 variables depicted here are nominal data. I can change the order of categories to fit my personal preference, and it has no impact on how I view the data. One category is not higher than another. I could easily change the categories of region to be West, South, Midwest, and Northeast. Or instead of words, I could use numbers, as is the case with my PSPP example. By contrast, ordinal data is also categorical but has an intrinsic order to it. I can arrange the categories from lowest to highest or highest to lowest, and the ordering will make sense intrinsically. educational attainment, shown here, is a variable that is often expressed as an ordinal variable. It expresses the highest level of education attained by the respondent. However, unlike numeric data, there is no specific unit that measures the distance between each of the categories. I could not say that graduate degree is 2 times higher than some college. Interval and ratio data are both types of numeric data. This data is ordered, but it is also measured in specific units. You could plot this data on a number line, and you could say that one value is 2 times higher than another value. These are ideas that make sense with this type of data. The difference between interval and ratio data has to do with the use of the zero term. The zero term in interval data is simply a placeholder in the number line, while in ratio data, the zero term is what we call a true zero. That is, it indicates a lack of the quality that we are measuring. Temperature scales help us to understand the difference between interval and ratio data. With degrees Fahrenheit, a value of 0 is not a true zero. There is still heat at 0 degrees, only less heat than there is at 50 degrees. By contrast, 0 degrees Kelvin is ratio data. It has an absolute 0. The value 0 in the Kelvin scale indicates the absence of any heat at all. We will start the course using the same techniques for numeric data, whether it is interval or ratio. But as we move into more advanced topics, we will see a special case in which counts, a kind of ratio data, have their own techniques. The general rule in statistics is that we want to analyze the data at the highest level possible. Numeric data is regarded as higher than categorical data, and we think of techniques for numeric variables as giving us more sophisticated results than techniques for categorical data. When possible, we want to convert our data to the highest level. However, there are frequent exceptions to this rule, so frequent that we can't even call the exceptions rare. Income and poverty level can both be expressed as numeric variables, but we frequently revert to categorical data to express them. There are several reasons why a data analyst might revert to a lower level of measurement. We may want to protect the confidentiality of the respondent. If I did a survey of YSU employees and had income data attached, I would know which responses came from President Jim Tressel because his annual income is way above everyone else's. A categorical measure of income would protect his confidentiality. Second, people recall certain pieces of information better in a categorical form. You probably cannot tell me exactly what your income was last year to the exact dollar, but you can tell me approximately the income range in which you fall. Also, there are times that the data itself begs a categorical form. Certain techniques, though appropriate for numeric data, sometimes give us clearer results if the data is categorical. And sometimes reverting to categorical data allows us to highlight obvious breaks in the data, as is the case when we look at levels of poverty. A special situation is binary data, which takes a 0-1 format. It's a situation we get when we have only 2 categories, such as male-female, yes-no, or true-false. Although the binary response is categorical in nature, binary data has numeric-like qualities that allow us to upgrade categorical data if we are clever. We will learn more about this in another video. We can also refer to statistics in terms of level of analysis. Univariate techniques deal with only a single variable, such as was the case earlier in this presentation when I found the frequency distribution for region. Bivariate techniques tell us the association between 2 variables. Multivariate techniques are used when we have 3 or more variables. Inference is handled at the level of bivariate and multivariate techniques. Here we need to be careful with our language. SPSS has procedures labeled univariate and multivariate. The software is using those terms differently than I am using here. Students sometimes mistakenly use those procedures when I'm looking for univariate or multivariate results in assignments, but you should be aware I will never ask you to use those techniques in SPSS.